Hello everyone, this is Jim, and today I will introduce the high-speed input function of our LX6C and also AC60. And this is our today's content: high-speed input configuration, pulse and direction inputs, and the counter configuration. This video shows how to enable the high-speed input channel. In our software, double-click this local high-speed I/O and we can check this for counter to enable which channel to use. And here, for different counter, for each counter we can set the different counting mode and the signal source. Here we have 6 counting modes: AB phase 1 type, 2 times, 4 times frequency counting, and CW, CCW, pulse direction and single phase. For the signal source, for example, for this AB phase, we have 4 settings. Here DI0 means X0 and DI1 means X1. Di7 means X7. For the encoder setting, we have 2 different running modes of our encoder: rotary mode and linear mode. For the rotary mode, we can set the rotation per rate of this mode. For example, 360. It means when the counting value achieves 360, the counting value will come back to 0 and increase to 360 again. Where will we use this? For example, we need to we need to record the angle between 0 and 360. Then we can set the period of our rotary mode as 360. So here, the counting value 100 will means 100 degree. And also we can set the counting ratio of our value. The default relationship between the input pulse and the user unit is 1.1. Is 1. So it means how much pulse we received, how much the counting value you will see in the function block. And now I will use this pulse and direction input to take an example. First, let's configure this counting mode as pulse and direction, and use X0 for pulse input and X1 for direction input. Here I connect Y0 to X0, Y1 to X1, and also Y2, Y3. All output terminals are connected to input terminal to simulate the encoder input value. And in this picture, you can see HC counter. This function block is used to enable our counter, and also MC power is used to enable our pulse axis, and this MC drop is used to send pulse. Let's check this video. When we set on this drop forward, the counting value will begin to increase. And here we change the drop direction, and you can see the counting value will begin to reduce. Okay. This is linear mode, and let's check the encoder rotary mode. Here I set the rotary period as 360 60. Okay, so you can see here when the counting value achieves 360, it will change to 0 and increase again. And this is another direction. It will reduce to 0 and begin from 360 and reduce to 0 again. Just different direction. And also for this HC counter, you can see here this invert input terminal. This terminal is used to change the counting value, counting direction. And now I will introduce some counter configuration. Here before the counting mode, and you can see 4 settings: hardware reset, torch pop, preset, and compare outputs. I will introduce them one by one. First, hardware reset. Here we have two selections. DI2 is used to reset from DI0 to DI3, and the Day6 is used to reset from Day4 to Day7. Let's check this video. You can see when we give the hardware reset signal, the counter will stop counting. Okay, so this is the hardware reset. It's easy, and now I introduce compare output. We have 4 terminals could be used to output Y0, Y2, Y4, and Y6. And for this function, we need to use this function block to use. Compare is this exit is used to enable this function block, and the position is the compare setting value. Output enable, usually we set it as true. It means we will use our configured hardware output. So every time when the counting value achieves this compare setting value, our PLC will give an output terminal, output signal. And for output type and output value, here we have two types: time and pause. So it means we can set, for example, to output 2 seconds signal or output 10 second signal. This is for time. And also we can use pause. For example, we set it as 1 and the pause range we set it as 1000. It means when the trigger value, when the counting value achieves the compare value, and the terminal will begin to output, and until the counter receive another 1000 pulse, the output terminal will turn off. So this is two different output type. Let's check them in program. First is the time output. Here I set the output time as 2 seconds, and then the compare value is 200. Enable this function block, and here begin to set the pause. You can see when the counting value achieves 200, this Day6 is turned on because we connect our D06 Y6 to X6. And after 2 seconds, this signal will disappear and X6 will turn off. Okay, it's turned off now. Now let's check this post output. Here I set the output port number as 720. It means the output terminal will turn on until our counter receives another 720 pulse. Then it will turn off. Then let's enable this function block. And begin to send the pulse. And here, when the counting value achieves to 200, this X6 is turned on. And until our counter receives another 720 pulse, it will turn off. Okay, so this is the usage, two different usage of these compare outputs. Preset. This preset function is a little similar to hardware reset, but the difference is for preset we can set different value, not only 0. We can set the preset value as 1000, 2000, 10, 200, and so on, any value. And usually the trigger signal of preset is a rising edge. So after we preset one time, if you want to preset again, you need to run the function block again. But for this hardware reset, until you unless you disable hardware reset signal, otherwise the counting value will always be reset as 0. And also, the preset terminal is Di2 and Di6. Di2 is used to preset from Di0 to Di3, and Di6 is used to preset from Di4 to Di7. And for these two, we can't use them together because we can't use same Di terminal for two different functions. And here, they also have a function block about preset. In this function block, we have our preset value, position, and then the trigger type, instruction rising edge, and the X rising edge. So it means we don't have to configure the hardware input terminal to preset our counter. You can directly use this function block rising edge to preset your counting value. First, let's check it. First, we use instruction rising edge to preset, and then the preset value is 100. Begin to counting and enable this preset. You can see the counting value will be preset to 100. And now let's change this preset value as 0 and check it again. Okay. Now let's change the trigger type to X rising edge. So now we will use external input terminal to preset. Here we need to enable this preset and disable this hardware reset because we can't use them at the same time. Okay, and then run this function block. Now it is in busy status. And we give the preset signal Di2. You can see the value will be preset to our setting value. And here you can see the outputs terminal will turn on. And now let's change the preset value to 0 and test again. Okay, so this is the usage of our preset function. And the last I've introduced the touch prop function. This function is mainly used to record the counting value when our PLC receives the external input signal. Compared with position reading signal, this touch prop will get an will reduce the error, because if we use MC read actual position, this function block or something else, or move some function like this, there will be an error between the actual value and our record value because of the communication cycle. So that's why we will use this touch prop function to get the correct counting value. And we have this HC touch prop for this function. Here is the introduction about this function block. We have prop ID 1 and 2. And now I configured X3 as prop 1 and X4 as prop 2. Trigger edge, we have rising edge, falling edge, and double edge. And for the trigger mode, we have single trigger and continuous trigger. For example, we are using X3, so when we run this function block and we get the rising edge of X3, the counting value will be recorded at this post position. And if you are using falling edge, the counting value will be recorded at this next position when we get the rising edge of our X3. And for single trigger means after you get the record value, this function block will finish it, output done. So it will not update anymore. If you want to get you want to update the counting value, you need to disable and enable this function block again. But for continuous trigger, it means this function block will always be in busy status, always running. Every time when you get the rising edge or falling edge, the positive position or negative position will be updated. Now let's check that in our software. Here I'm using pop 1 X3 and X rising edge single trigger mode, and enable this function block. It will change to busy status. And now let's give the pop 1 signal rising edge. So now you can see the position will be recorded in this post position. And now I change it to a falling edge and also use X3. Now let's give a falling edge of X3. You can see the position, counting position will be recorded in this next position outputs. And then last, here I change to continuous trigger mode and also use falling edge. So here every time when PLC receives the falling edge of X3, the counting value will be updated in this neck position. Okay. And now let's change the trigger mode. Oh, sorry, let's change the trigger edge to double edge. So now every time when we get the rising edge of x3, this positive position will updated, and every time when we get the rising edge of x3, this negative position will be updated. Okay, so this is the usage about HC touch function. So this is the usage about HC touch probe. If no questions, let's invite our Molly to